Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to increase the length of a line segment using a compass and straight edge. How are we learning it? Through the scaling a line segment notes and the scaling a line segment assignment. When can we use this information? To recreate a piece of furniture or decoration by increasing its size. How do you know you learned it? By getting a score of 4 on the scaling a line segment assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the scaling a line segment notes, and then I'll give you time to complete the scaling a line segment assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the construction study guide and any incomplete assignments that you may have. Let's take a look now at the scaling a line segment notes. The notes begin with the learning goals and success criteria. So what is a line segment? A line segment is a straight path that has endpoints on either side. So it looks like this. So we have a line here and it ends on both sides. Now, how is that different from an actual line or a ray? Well, a line segment has endpoints on both sides. A ray extends without end, meaning it goes on forever in one direction and has an endpoint on the other side. So here we have an endpoint, and this one goes on forever this way. And then a line extends forever with no end on both sides. Symbolic notation for line segments. When we talk about a line segment, we label it as AB. So it's the two endpoints, so A and B. So if this is A, this is B, we would call this segment AB. And it's written just like this. Geometric notation for line segments. Line segments are shown geometrically by labeling the endpoints on the line segments. A dash is typically drawn through the line segment to demonstrate the segment length. So for instance, we have a segment here with these two endpoints. Congruency and similarity. Congruent line segments are line segments that are of the same size, shape, and angle measure, so they're exactly the same. And the way we write that is AB is congruent. This symbol means congruent. So AB is congruent to CD. Similar figures have the same shape and angle measure but have a different size. So we'd have a line segment that is half of the original or a third of the original or something like that. And the way we write that is AB is similar to CD. So congruent is an equal sign with the squiggly over the top. Similar is the double squiggly. So congruency versus similarity. Congruent figures have all the same sizes. So notice all of my triangles here, both of my triangles, have exactly the same angle measures and same side lengths. They look exactly the same. That is congruent. Now similar means that it's blown up or shrunk down. So it's all the same size and shape. It's proportional, but it's not the same size. It blows up or shrinks down. So we can see that this triangle here is this one blown up. Geometric notation for congruent line segments. So line segments are shown geometrically by labeling the endpoints on the line segments, and congruent segments will be shown with the same number of dashes through the sides. So for instance, we have a triangle here, and on this side, you can see we have a single dash, and on this side, we have a single dash. That means that those two sides are exactly the same length. Then we have a double dash here and a double dash here. That means those two side lengths are exactly the same. Now, what is scaling? Scaling is multiplying or dividing the length of a line segment or measure of an angle by some value. So, for instance, we can scale a line segment by copying the segment length and adding it to the end of the existing segment. Scaling an angle involves copying the angle measure and adding it to the end of the existing angle. So here's an example. We have a segment here. It goes from here to here. If we were to copy that afterwards, just extend it on and copy the same distance, now we've doubled it. If we did it again, we could triple it, and so on. Now here, with an angle, we have an angle that we start with, and here it is again. And then if we copy that angle on top of the existing one, now we have an angle that's exactly twice what we started with. Now here's a video showing you how to scale a line segment using Desmos. So go ahead and watch that video now. So let's take a look now at how to use Desmos to scale a line segment. So we're given a segment here and we want to double it, make it twice as long. So we're going to go ahead and go to our tools. And the first thing we need to do is extend this line segment and make it go longer. So we're going to use the ray tool and click on this point and this point. And all that did was extend the line. Now we can copy this distance further down, and wherever it crosses, that should be where double the line segment would be. So we're going to use our compass tool because we already have our radius here. So we're going to click on that, and notice it gives me a circle with this radius. Well, I want this to start right here, because now this is 1, and this would be exactly double right here. So we're going to go ahead and put a point where it intersects, and that would be exactly double our original segment. If we wanted to triple it, we would just do that process all over again. So this is how you can use Desmos to scale a line segment. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account. And it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Scaling a Line Segment assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. We'll go ahead and click on that. And it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The assignment begins with the learning goals and success criteria. We'll go ahead and click Next. Now, it says use a compass and straight edge to construct a line segment that is double the measure of the line segment below. So what we're going to do is use our tools. So we pop that out. We can drag this over a little bit so we can see it. If we need to move it around a little bit, that's okay. Might need to angle it so we have some space. And then we're going to use our ray tool to extend it. So we click on this point, and notice it took my line segment and extended it out. Now we need to copy this distance over here, and that would be exactly double. So we're going to go to More Tools, Compass, and we're going to click on this segment. Notice it now gives me a radius with that distance I want. If I bring that over to here, now notice I have a radius here and a radius here that are exactly the same. So that means that this point here represents a segment from here to here that is exactly double what I started with. Then we'll click Next. So let's take a look now at how to use Desmos to scale a line segment. So we're given a segment here, and we want to double it, make it twice as long. So we're going to go ahead and go to our tools. And the first thing we need to do is extend this line segment and make it go longer. So we're going to use the ray tool and click on this point and this point. And all that did was extend the line. Now we can copy this distance further down, and wherever it crosses, that should be where double the line segment would be. So we're going to use our compass tool because we already have our radius here. So we're going to click on that. And notice it gives me a circle with this radius. Well, I want this to start right here, because now this is 1, and this would be exactly double right here. So we're going to go ahead and put a point where it intersects, and that would be exactly double our original segment. If we wanted to triple it, we would just do that process all over again. So this is how you can use Desmos to scale a line segment. And we'll continue to click Next and do the same thing until we get to slide 6. On slide 6 now, it asks you to construct your own line segment and then create a duplicate of it that's exactly double its size. Then on slide 7, it asks you to do the same thing, construct a line segment, now triple it. So now we should do it twice. And then we'll click Next. The last question says, is it possible to scale a line segment 4 times? Well, yeah, we can do it again, right? 4 times. How about 5 times? Yes. Now, is there any limit to the number of times we can do it? Could we do it 100 times, 1,000,000 times? Yes, we can. So there is no limit to it. Explain your thinking. So explain why there's no limit to the number of times we can do this. So you'll go ahead and do that. And then once you're done with that, you'll go ahead and go back to your Google form and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.